Welcome back. In this episode, we'll take a significant step forward by connecting our Spring MVC application to a MySQL database using JPA. By the end of this session, you'll have a complete vision of how data flows from your database to your view and back. Let's dive in. Before we begin, let's quickly go over the tools we'll use. WAMP, our local development environment for MySQL. Ensure it's running. IntelliJ IDEA, where we'll write and test our entire Spring application, configure JPA, and use Thymeleaf. For dependencies, make sure to include the following: Spring Web, to build web applications; Spring Data JPA, to interact with the database using Java Persistence API; MySQL Driver, to connect Spring to a MySQL database; Thymeleaf, for dynamic HTML rendering. If you're not familiar with these tools, there are plenty of beginner-friendly resources online to help you get started. We'll start by creating an entity called LatteOrder. This represents the data structure we'll store in the database. Here, @entity tells Spring that this class maps to a table in the database. The @ID and the generated value annotations specify that the ID field is the primary key and will be auto-generated. Fields like order name and price correspond to columns in the database table. Additionally, we include a default constructor and getter or setter methods to ensure proper functioning of the JPA framework and to allow easy manipulation of the data. Now, we'll configure Spring to connect to MySQL. In the application properties file, we'll add our database credentials. Let's break down what each row means. Spring application name sets the name of our application. Spring data source driver class name specifies the driver for connecting to the MySQL database. Spring Data Source URL defines the connection URL to our database. The create database if not exist equals true ensures the database is created if it doesn't already exist. Spring Data Source username and Spring Data Source password provide the database credentials. Spring JPA Hibernate DDL Auto automatically updates the database schema based on our entities. Spring JPA Show SQL displays SQL queries in the console for debugging purposes. Logging levels. These rows configure detailed logging for Hibernate and Spring Web to help us debug any issues. Next, we'll create a repository interface for LatteOrder. This interface extends JPA repository, giving us access to CRUD methods. Let's break this down. The first parameter, LatteOrder, refers to the entity class that this repository will manage. In our case, it represents the LatteOrder entity. The second parameter, long, specifies the type of the primary key for the entity. Since the ID field in LatteOrder is of type long, we use it here. By extending JPA repository with those parameters, we inherit a set of built-in CRUD methods to interact with the LatteOrder entity. For example, we can save, fetch, update, or delete orders without writing any SQL. The service layer acts as a bridge between the repository and the controller. Notice how we inject the repository into the service using constructor injection. The service does not access the database directly. Instead, it relies on the repository to handle all database interactions. Let's take a look at the getAllOrders method. Notice how we fetch all the orders from the database using the repository's findAll method. The method then returns the list of LatteOrder objects, so it can be passed to the controller and displayed in the view. This service method keeps our code clean and reusable, as it encapsulates the logic for fetching data in one place. To keep things simple for now, we are preloading some data into the database through the repository in the main class. This ensures that when we test the application, we already have data available without manually entering it. This method initializes the database with some sample orders when the application starts. In future episodes, we'll replace this with dynamic data entry. Now, let's create a controller to handle HTTP requests and interact with our service. Here, the @controller annotation marks this class as a web controller. The @getMapping method retrieves all orders from the service and adds them to the model, which is then passed to the view. Finally, we'll create an HTML page to display the orders dynamically. This page uses Thymeleaf to dynamically render the orders data passed from the controller. Each LatteOrder is displayed in a table. Let's test our application. Start the Spring Boot application. Navigate to Orders in your browser. and you should see the data displayed dynamically. This data was preloaded into the database from the main class when the application started. This approach allows us to focus on testing the flow without needing to manually insert data. In the future, we'll show how to fully integrate this with dynamic database operations. Congratulations! You've just created a complete data flow from MySQL to a dynamic view. In the next episodes, we'll return to each phase: entity, repository, service, controller, and view, dedicating a focused episode to dive deeper into their concepts. We'll also expand this project by adding more entities, relationships, and advanced features. Stay tuned.